Hi guys, today we're going to be going over the standard 8.PS4.3. This is about waves and their applications and technologies for information transfer. Specifically, we are going to evaluate the role that waves play in different communication systems. And if we think about that, we start with radio, we have television, we have cell phones, and we have different satellites that are used, and we're going to be talking about those today. As a quick refresher, let's look at the electromagnetic spectrum. Right here you see the visible spectrum being highlighted in the middle. And then on the lower energy side of it, you have the radio waves, you have microwaves, which are not written in there. And then there's the infrared rays. Then you have your visible spectrum, which goes from red all the way to violet. On the red side, just below the red would be the infrared. It would have just a little less energy, and therefore we can't see that with our eyes. And then on the higher end of the visible spectrum, where the energy is a little more increased, you have violet, and that's beside ultraviolet, which can damage skin cells, but it's also kind of good for you in limited amounts to help produce vitamin D. Then you have X-rays on the higher energy, and then gamma rays are the highest energy of all on the spectrum. And so those can be very damaging if not used correctly. Remember, the visible spectrum is Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. And that is the visible spectrum. We're going to specifically be looking at this part of the electromagnetic spectrum where the radio waves and the microwaves are. You will see there's actually radar is also listed, and that is uses microwaves to enable that. Okay, as we talk about wireless communication, we're going to start with broadcasting, and this is where charged particles are vibrating inside transmission antennas. Now, we've talked about this in our overview in part 2 of the PowerPoint, but this is going to be more specific to this particular standard. But there's charged particles are vibrating inside transmission antennas to produce those radio waves. And then these antennas will send out waves in many directions. And this information is carried to a receiving antenna and converted into an electric signal. I have a really good friend that on his car he has this radio antenna, and a lot of you may have those. And he went through a car wash and knocked the antenna off. So much for him being able to listen to the radio at that point. So you do have to have a transmission antenna, but then you have to have something to be able to receive it. Now, this signal that you is the sound that you end up hearing. If we think about the radio spectrum, the different radio frequencies are assigned for different uses to prevent interference. You have radio stations, taxis, and police use different bands. There's even a citizens band radio that sometimes called the CBs that the truck drivers used. I don't know if they still do. I imagine they do, but it's back in the day, you might have seen the movies of Smokey and the Bandit when they had their own language that they spoke on the CBs, and it was quite a fad there for a while. And then there's some home-based CB type home-based stations, where they can really talk to people a long way away. But they're doing this on a very low energy, low frequency type of device. But now taxis, police, and any emergency personnel, they're going to have their own particular band. That's so they don't get a lot of insignificant conversations on there. You don't want a lot of bleed over. And so that's one of the parts that is actually regulated. As I had mentioned before, uh, the radio can be AM or FM. And AM is amplitude modulation, and FM is frequency modulation. And if you remember back to talking about the different waves, amplitude was one of the measurements of a wave, and that is how high the crest of a wave is in relation to its resting point from the midpoint. It doesn't measure from the trough to the crest, but just from that resting point up. And then frequency is how often a wave passes a particular point um, within a given amount of time. And we remember that they are actually measured in hertz. And the hertz is how many times the wave passes in 1 second. When we look specifically at amplitude modulation, then think about that as an amplitude change. That's the only thing that's going to change. The amplitude of the wave changes, but the frequency stays the same. The same amount of waves will go through, but the amplitude, the distance of the crest from the resting point, will be higher. These are very, very long wavelengths, and they're very, very low frequencies and low energy. Considering they have such low energy, they are trapped by our ionosphere, and they bounce back off of it, and therefore they can travel a further distance. But it's really not a great signal. Just for fun, you might click over onto the AM button on your radio dial and listen, and you get a lot of interference in that. But those can travel a long distance, but at the same time, they're not very high quality. The other type of radio signal is the frequency modulation, or FM, which a lot of you listen to. In this situation, the frequency is what changes. The amplitude, the distance from the crest to the resting point, is the same, but the frequency, the amount of times the wave, the amount of waves per given period will increase. And so it has a little higher energy. Now, this higher energy will allow the waves to pass through the ionosphere. They are not reflected back down where they can bounce around and be heard for long distances, but they do have a better sound quality. Another type of wireless communication is a cell phone. When a call is placed, it sends out microwaves tagged with a unique phone number. So you're holding in your hand that cell phone, and when you make a call, it's sending out a microwave to a tower. That tower then sends it to a central hub where it is decoded and then resent to another tower, or it could be back to the same tower, and then that is transmitted to your phone. I think I mentioned earlier in the other video that we had actually tried this in class to see how long it takes, and it was just so quick that a person could dial someone's number and that they would receive the call. It was very, very quick. So we know that microwaves travel extremely fast. The receiving phone rings when it picks up the signal, which is kind of common sense. And then another form of communication is the satellite communications. There are actually satellite phone systems. A lot of times military will use this because they need to make a call and to be heard around the world. They could be at very extreme remote places where there are no towers where you could call a regular phone. And so these radio waves are sent to a satellite, which then transmits those waves to the receiving phone, and they can be used anywhere in the world. We are currently doing a lot of TV watching during this um, quarantine time, and a lot of you have satellite TV systems. And in the same way, these TV signals are sent to satellites, and those relay them around the world. I remember when the first satellite dishes came out, they were extremely massive. They were just huge, huge, huge. They were about the size of a trampoline sitting out in the yard, and then they would have to be aimed to a particular direction to pick up the signal from the satellite. And then inside there was a box, and when you would turn the box, the satellite would rotate and roll back so it could pick up another satellite to get another channel. We thought it was pretty fancy back in the day and was very expensive, but it did take a while to actually get the right signal. Now have a lot better technology as far as that's concerned, and a lot of you may have the little satellite dish up on your house or sticking out in your yard, but those don't move. Those are pretty well set after they are first calibrated by the technician who comes out. But these signals will also be scrambled in an effort to make money, which they need to be able to do to stay in business. Um, they offer subscriptions to particular channels. Some of you may have a particular channel you like, and therefore your parents are paying for that, either through a package deal or they might actually have a particular um, a channel that they would like to watch, and so they will pay for that particular subscription. But the satellite dishes and decoding boxes are needed to unscramble them. Some of you might have a cable box where its main purpose is to unscramble the stations that you have actually paid for. And so this is another way that wireless communication uses the radio waves or the microwaves. Another type of communication, and it's the last one that we're going to talk about on this particular video, uh, is the satellite communication that enables our GPS, our global positioning system. This tells you where you are. It's amazing that on your phone right now you can pull it out and you can actually get the coordinates of where you are. Now, when we talked about earthquakes and then how the waves travel out from an earthquake, um, we decided that there was a particular center or an epicenter, and then those waves would travel out in all directions. And it would require three different locations, three different seismograms to actually locate where on Earth that earthquake would have originated. The GPS would need three satellites to pinpoint your location. But sometimes we do a lot of traveling. We may be flying in an airplane, or we may be climbing up high in a mountain, or we may be digging, down low uh, under the earth. So we have to have a fourth satellite to be able to tell exactly how far above or below Earth's surface you are. So it is actually going to pinpoint you very, very precisely using that fourth satellite. So that's a little bit of a difference. But the GPS, or the Global Positioning System, will tell you your exact location on Earth or in the air. There are 24 satellites that broadcast radio signals to Earth. So that's quite a few of them. So just as a quick recap, let's think about this particular standard to evaluate the role that waves play in different communication systems. And we've talked about several of those, and I know this was a review for you. So hopefully it helps you to some degree. Uh, Remember radio, television, cell phones, satellite phones, satellite TV, and GPS. Those are some ways that the waves, the electromagnetic waves, can help us communicate with one another, which is very, very important during this time. Anyway, thank you so much for watching this video. I hope you're staying safe, and we will see you soon.